Hey guys, how's it going? This is Simon, and this is the first of what will be two videos that I'm creating to help you prepare for Test 3 in the UNIX security course at Mohawk College. In this video, we're working on Lab 6, which is titled Network Security, and what we're doing in this lab is expanding on our knowledge of IP tables and firewalls, and learning how we can really control the network traffic that comes in and out of our virtual machines. We're also going to learn something new called TCP wrappers, and this is a tricky lab. This is one that I am going to show you how to go through it. I'm going to show you what you need to complete this, but you really need to do your own research with all of the stuff, especially when it comes down to the IP tables, because I'm going to show you the statements that you need. Unfortunately, you have to understand them. And I'll do my best to explain them, but if you don't understand it, if you don't understand what I'm telling you, you might not do well on this test coming up, because very similar to the DNS lab in your Unix administration course, the littlest error or the wrong statement can be disastrous for your system. If you put a statement into your IP tables that is not what you intended, you might be allowing traffic into your virtual machine that you did not intend, or vice versa. You might prevent traffic that you do want to come in and out of your virtual machine. So you really need to understand these statements, why we put them in. I'll do my best, but if you have questions, please go see your teacher. Another thing that I have to suggest that you do before you start the lab is read this documentation top to bottom. The reason why is there's a lot of requirements. We aren't really given step-by-step instructions. We're given just requirements, and a lot of what we need to do right off the bat is given to us further down in the documentation. And I'll give you an example. Right here under general requirements, we have a line that says, before modifying any file, create a backup copy with the extension .prev. Grades will be awarded for the existence of these files. If you just start up here and you work your way down, you won't have done that for many files that you've modified. So you want to make sure you read everything top to bottom first, so that you really understand what you need to do and all the little requirements that need to go into each of these virtual machines. Another one that's really important to know is, once you're done this lab, do not delete the virtual machines, because we need to use them for labs 7 and 8. So make sure you keep these, because if you don't, you're going to have to redo this entire lab, and that might be a good learning experience, but it might be frustrating. So just make sure that when you're done and you're happy with this and everything's working the way you want, save them and make a backup. You might even need them for the actual test. I don't know. So just make sure that you have copies of these. Another thing is, it will tell us that in our network files we need to remove the hardware lines. So you're going to want to make sure you do that. And let's see if there's anything else important. Yeah, all servers must be built on the red network. So if we go up to our overview right here, we can see we're going to be creating a virtual machine that is called Gateway. The host name is going to be Geo1, and it's going to be on the blue and black network. But in order for us to do that, we have to make sure that we build Geo1 on the red network first, and we have to make sure that they're all patched. So you have to make sure you do that before any of these virtual machines leave the red network. So there's a lot of things that we need to do. I'll do my best to explain why I'm doing what I'm about to do and reference anything that was a requirement down here, but it's probably in your best interest that you go through everything first. So I'm going to assume that you've already done that, and we can begin this lab. First thing that I'm going to do, I've already downloaded this script. I'm going to put this script on BO1. So I'm not even going to worry about anything here yet. We're not going to do anything with this lab. All I'm going to do is take the script that I downloaded. So go ahead and download that. And I'm going to put it on BO1 so I have it on BO1. So get BO1 ready. Use the one that you've used for lab 1 or 2, whichever one that you have available. Go ahead and load up BO1. As long as it's working, that's all that matters. I'm using my build server BO1 from the server that I completed in lab 2. But again, lab 1 will be sufficient. And I'm going to make sure that I'm connected, or that I have the ability to connect to the build server from my virtual machine. This is going to change. If you look at the overview, our host is going to have a different IP address and network from the build server. But for now, I'm going to disregard it, and I'm going to use the build server the way I typically do in most of the labs previous to this one. So I'm going to go into my network adapters and just make sure I'm good to go. Here's my VirtualBox host only network adapter. I'm going to go into properties, And this is good. If you have something like this, that'll be good for now. Like I said, we will change this, so you can hit OK, close this, and just minimize this window for now. You can close this one though, and start up your build server. Again, what I'm doing is essentially just transferring the script to the build server, and once I've done that, then I can start to really mess around with this lab. But you'll see that it's probably easier in the beginning to get this script onto the build server and then distribute it to the router and the gateway while it's on the red network than trying to do it once you've done everything, because if anything's not working with your IP tables, you might not be able to get that script onto those virtual machines. So let's just get it onto BO1 first, and then we can go into the actual lab and play with it. So I'm going to log in as root, and going to just cd or change directory into the temp directory. I'm going to go into the command prompt of my host machine, and I'm going to type in this command pscp. This will work if you have putty, so make sure you have putty. We don't necessarily need putty for this lab, but I am going to use it in this case just to transfer the file. And find the file that you downloaded onto your host machine. hostinfo.sh, and we're going to give it to root at 10.1.1.20, and I'm going to put it in that temp folder, type in my password, and there we go. Once you've done this, then you can close the command prompt. I don't think you're going to need it anymore. So I'm going to exit that out. Just going to check that BO1 has this, so I'm going to type the ls command, enter, and I can see it's right there, so I should be good. Now what you can do is go back into the VirtualBox host only network adapter, and we're going to go into the basically IPv4 properties, and we're going to change this. We want to change it so that it represents the IP address that is in this diagram. So it should be 10.3.1.1, and then your subnet mask has to represent this. We have a prefix of 16, so it means the subnet mask can be 255.255.0.0. So if it looks like this, you should be good. Go ahead and say OK, close, and now you can close this window. Now with BO1, I want you to shut this down. So shut down -H now. What we're going to do is we're going to go and change the actual network settings. So we're going to go to settings, go to network. Where it says host only adapter, we're going to change it to internal. The reason is down here we can see it's on this red network, and we can see it should be on the internal network, and we're going to call it red. So change it to internal network, change the name to red, and then go to advanced. If you don't have your adapter type as fast3, make sure it's fast3. Typically that didn't matter, but in this case it does suggest that we want to make sure all of our virtual machines are using the same adapter type. So we're going to make sure it's fast3, hit OK, and start the build server one more time. So what we're going to do is this first. We're going to start with requirements part 1, which says configuration BO1. And these are pretty simple instructions. It says update the host file. What we're going to do is go down here. We have recommended host file additions. I can see BO1 has this suggestion, so we're just going to copy that into our host file. So right here, I'm going to log in as root. We're going to use the VI editor to edit the host file. So it's located right here. We are going to add 3 lines. First one is 10.1.1.1, and that's going to be R01 and R01 red. Then 10.2.0.1, and that's going to be R01 blue. And finally 10.2.0.10, and that's going to be G01. So G01 is the final. We can save that and close. And now we're going to add an explicit route to 10.2.0.1 by creating this file. So basically it's root-eth0, and all we're going to do is add these 3 lines. So let's do that. Go into the VI editor, /etc/sysconfig /network-scripts, and then /root-eth0. Enter, and let's add those 3 lines. So address 0 equals, I'm going to say 10.2.0.0, so that is going to be the blue network. Netmask 0 is going to be 255.255.0.0. So if you look at the blue network, we have a prefix of 16, so we are going to use this netmask for that network. And then finally, we have a gateway 0, which is going to say, if we're trying to get to the blue network, have this build server go through this port right here, which is the eth0 port of the router. So we're going to say 10.1.1.1. Go ahead and save that, and then type in service network restart. Everything should be fine. Perfect. So we've just completed this section right here. We did not need to do a backup of anything on BO1 because the script that you're going to run on the router and the gateway don't look at BO1. So in this case, we could skip the actual backup. It's probably a good thing to do in general when you're in an actual real working environment, but for now, we can skip the backup copies for BO1. Let's make router. So we're going to make the router virtual machine, and I'm just going to do it one by one. I'm going to get this guy going first, and then we can work on gateway. So all I'm going to do is edit the default kickstart file, and we're going to basically cater it to the router. So go to the VI editor, edit the kickstart file. Again, the default is fine. We'll make it easy for ourselves in this case. Hit enter. What we're going to do is we're going to add 2 network statements. So we already have one, so we're just going to add one more. But the first network statement is going to be catering to this IP address, and that's 10.1.1.1. We're going to have the host name as R01. We're going to have the netmask as 255.255.255.0, and it's going to be a static IP. So type I. Network is fine. Boot proto changed from DHCP to static. Device is fine. Host name, change it to R01. And then we're going to add --IP 10.1.1.1. And we are going to add --netmask 255.255.255.0. So that's the first network statement down. Let's get the second one. The second one is going to have an IP address of 10.2.0.1. The device is going to be eth or ETH1. We don't need a host name anymore, but we are going to make sure the netmask is going to be 255.255.0.0 because we have a prefix of 16. So it'll look like this. Network --boot proto static device IP netmask. There we go. Now let's just make sure that we edit our host file. So we're going to make sure we add this to our host file. All I'm going to do is go down to the bottom of this actual kickstart file, and I'm going to say echo 10.2.0.1, and it's going to be called R01 blue. Append it to the host file. Next one will be 10.1.1.1, which is R01 red. Append. 10.1.1.20, that's B01. Append. And finally, we're going to put in G01. And that should be sufficient to get R01 to install properly the way we want. We don't have to put any users on R01, and everything else should be fine. So let's minimize this. Let's go to VirtualBox Manager and create R01. Go to it just closed on me. That's fun. Alright, it's still there, so that's good. So I'm just gonna go to settings. We'll make sure the boot order is good to go. That's how my boot order is. You should at least have hard disk and network checked off and at the top. Add a processor. We'll go down to network. Now in this case, we have to look at what we're dealing with. With router, or with the router, I guess, adapter 1 is going to be your F0 port, and that's going to be on the red network. So we have to make sure that it's attached to internal, name it red, go to advanced, and change the adapter type to fast3. Then we're going to add a second adapter, and this is going to be on internal blue. So we're going to say internal blue, and once again, adapter type fast3. Once you've done that, you should be good to go. So go ahead and hit OK, start the machine. I hope it loads. Hit cancel. You are going to see something new if you've never done if you haven't done a kickstart boot with two NICs. You're going to see a message that asks which NIC you want to use, and just hit enter. The first one is what we want, which is F0, but I'll show you what that looks like. So this is what it looks like. We're going to get something that looks like this. Just hit enter. We want F0, so there we go. It looks like it's good. So while this is doing its thing, what I'm going to do is change the kickstart file to prepare for the gateway. I'm just not going to save it until I know that R01 has officially booted and everything's good. So let's go back to B01. Just gonna clear this. Let's edit that file again. And now this is where it gets a little bit tricky, because obviously we have gateway right here and it's on a black and blue network, but we need to make sure we build it on the red network. So when it comes down to each of the ports, we can see S1 and S0. S1 is on the blue network, and thankfully S1 is also the same port on the router that is on blue. So basically, each port that is on the blue network for both the gateway and the router are using the S1 NIC. So what I'm going to do is I'm going to first start by editing the network, the second statement in our default kickstart file. So you can go past the first one, go to the second one. Boot proto-static is fine. Device F1 is fine. IP is where we're going to change it from 10.2.0.1 to 10.2.0.10 because that's what this is. And the net mask is fine, so that's all we had to change. But we have the first network statement that does have to change. Now, we don't want it on the black network yet. We have to make sure it's on the red network. So technically, the net mask is fine. We don't want the hostname R01, so we're going to change that. But the device and the boot proto is fine for this. All we're going to do is change hostname, and we're going to give it an IP address that falls in line with the red network. So I'm just going to call it 10.1.1.5. Whatever you write down, make sure you remember that, because there's one step that we will need to use that IP address when we are on the red network. But if you want, if it's easier, just follow what I did. Just put 10.1.1.5 for now. And now we'll go down and edit the host file. The host file, all you need to do is just get rid of the last line. And if you want, you can type in R01 for the first line. You can add another name entry. So you can do that. And I'm just following what's right here. So if you're wondering what I did, I'm just following this right there. I put it in here. We should be good to go. So before I save and quit, I'm just going to make sure that R01 is good. So I can see R01 is good. I can minimize this, and let's save and quit on the build server. Let's minimize this and create G01. Go to settings, get the boot order where it needs to be. Go to network. Now here, once again, we have to check out what we're doing. So the first NIC card is your F0, but we don't want it on 10.3.0.10 or the black network. We're going to be putting on the red network. So for now, we're going to be changing this to internal, and the name is going to be red. Go to advanced and change this to PC Net Fast 3. Go to adapter 2, enable it. This one will be internal network blue, and change the adapter type to Fast 3. Go ahead and start that machine, and you can minimize the manager for now. Cancel this. There we go. And you get this message again. That's okay. Just hit OK or hit enter and let it do its thing. So while this is doing its thing, what I'm going to do is I'm going to go into the router, and I'm just going to make sure that I patch it and I update it. So let's go into the router, log in as root, put in your password. I'm going to say yum update. Yes, yes. And there we go. We've updated it. We should be good for the update for the router. If you want, you can go into the build server, and what we can do is send that script over to R1. So the script that we basically downloaded the first time was in our temp folder. So I'm just going to say scp/temp/hostinfo.sh, and we should be able to do this because we haven't really changed anything with our IP tables yet. So I'm going to say root at, and we can say R01, and then we can say, we'll put it in the temp folder. Say yes, put in the password, and there we go. So now if I go to R01 and I just list the contents of temp, I should see the hostinfo.sh script, which is great. So that is good. So let's minimize R01 for now. I'm just going to check on G01. It's almost done. I'm going to wait for it to finish, and then I'm going to update it and get that file as well. And then what we can do is start with the second step, which is configuring R01, and this is where we're going to be basically working with IP tables and some of the SSH files. We have to remember to back up a lot of our files that we're going to be modifying and just make sure everything's right. So this is where things can get tricky, but I will explain everything I can. So we're almost done with G01. Alright, G01's there. I'm going to log in as root. First thing I'm going to do is update this. Yum update. If you want, and this is probably something we should have done, we should have just checked that everything is the way we want it. So we can say if config, I'm just going to pipe it over to more so we can make sure we can see everything. So our first NIC has 10.1.1.5. We did not want to have this when we finish the lab, but for now we need this just to get the file that we want from BO1. And we also wanted to make sure that we had this so that we could patch it properly on the red network. So for BO1, let's just do the same thing that we did for the router. Send this file over. We're going to send it to root at, but you can't put the host name of G01 because it has a different IP address. So right now we're going to type in 10.1.1.5 because that's what I put in the Kickstart file. That's what we have right here. This is why it was important to remember that. And we're going to hit enter. Yes. Put in the password. There we go. Let's just minimize BO1. And in G01, we're just going to check that it's there. So if I list the contents of the temp folder, we can see that script is there. So we should be good. For now, we're going to minimize Geo1. We will change it and make it go on the black network eventually, but for now, let's work on just the router. So I'm going to minimize this. Let's go over to R01 and let's play with R01. So let's clear this. First thing that we're going to do is let's read all of these requirements, because there's a couple things that we're going to want to modify, and my suggestion is you make backup copies first before you do anything. So first thing it says is we want to allow SSH from blue to red. So that means blue should be able to SSH into red, but red should not be able to from blue. We want to allow HTTP from blue to red, so same thing. Blue, anything on the blue should be able to HTTP into BO1, but it shouldn't go the opposite way. And then we want to allow pings both ways. So we want to allow everyone to ping each other essentially. Then it says allow nothing else. Okay. I'm going to tell you that this is all going to be done in the IP tables. So let's make a copy of the IP tables first. Let's go copy the IP tables and call it .prev. So put this command in, hit enter, and now we have a copy of it, so that's good. That was one of the requirements that was down here. Another thing that we have to do is make sure that SSH only listens on the blue network, which means we have to edit this file. So let's make a backup copy of this file. So we're going to say cp /etc ssh sshd _config .prev. There we go. So for R01, we basically made a copy of everything that we need to, because we're going to be modifying just 2 files as it stands right now. There is a second there's, I guess, like section F that says the default IP table firewall configuration might not allow packet forwarding. First, get R01 to work as a router without the IP tables turned on, then work on your firewall configuration. So one thing that we do have to do is make sure that R01 is actually a router. And how we're going to do that is by editing another file. So let's make a backup copy of this other file, and I'll show you where you can locate that. This is the file that we're going to be editing, so go ahead and make a backup copy. There we go, and let's edit that file. Let's do that first. So we are going to be using the VI editor to edit the syscontrol.configuration file. So it's /etc /sysctl.conf. Edit, and thankfully the only thing that you need to edit is this line right here where it says net.ipv4.ip_forward equals 0. We're going to change 0 to 1. Okay, there we go. So let's save that and quit, and once you've saved that and quit, you can clear this, and now we can work on the IP tables. We are going to restart all these services, but what I'm going to do is edit everything first, and then we'll restart it so everything gets restarted at the same time. If you want to restart it now, feel free to, but I'm just going to do it to save time. So let's go and edit our IP tables. So we're going to use VI editor and edit this file right here. And we have already a lot of statements in here that we are going to modify. Some of them we're going to keep, some of them we're going to get rid of. I'll try my best to explain what we're doing, but if it's confusing, like I said, go and ask your teacher or do some research, and they'll be able to help you a lot better than I will. But essentially, we have input statements, forward statements, and output statements, and I'll explain what each of them do. We are in the router virtual machine. So when we have an input statement, what that means is basically we can allow or reject anything that is meant to come into this virtual machine for this virtual machine. So it's not meant for anything else. Input is data coming into this virtual machine for this virtual machine. Output is anything going out of the virtual machine, so this virtual machine, meant for other things. So if I'm sending information out here for the build server, the gateway, out just means any data coming out of this router from this router. So the data coming out is specifically from this virtual machine. Forwarding means that it will forward data in and out of this virtual machine, but the data is coming from somewhere else. So it might be coming from the build server, it might be coming from the gateway, it might come from other servers, it might be coming from who knows. But essentially, forward means the data is not coming from or meant for the router, it's meant for other virtual machines, and it's coming from other virtual machines. So that's really the difference. Input, output, that is intended for the virtual machine or coming out of this virtual machine. Forward means the data is just going through this, but the data is coming from somewhere else and is meant for somewhere else. So hopefully that makes sense. If it doesn't, like I said, ask your teacher, but I hope that makes sense. I feel like that should make some sense because you already know a lot about ACLs. So this should be very similar. You just want to know if it's forward, it just means it's coming in and out. Input means it's coming in and staying in. Output, it means the data is coming from this and going out. So we have a lot of statements here. What we're going to do is look at this first statement. It says A input, M state. So it means match the state. And the state is established, related, and then J means jump, except. So it just means what are you going to do with this? This is an important statement to make. It basically says if there's already something that's been established, if there's a connection that's established, just keep it open. So we have something down here that says state new. That means you can make a new connection, but if you make a new connection, if it's not established, that means that it's not going to keep it if it's meant to keep going. So we need state, established, related to keep connections that have been made and keep them going. So this line is really important to keep because you want to make sure that, like I said, anything that you connected to, a new connection, has the ability to remain connected and remain, remain in a connected state with our virtual machines. So this one, we're going to keep that. Then we have another statement that says input P, so the protocol is going to be ICMP, so that's your ping, J accept. This means that we're going to accept pings, so that's great. We're going to keep that. A input, A means usually add or append, dash I LO, so that's your loop back, accept. So that just means if you're sending information that's supposed to be coming back to yourself, if you're trying to ping yourself or anything like that, accept it. And in this case, we don't have anything telling us that that's a problem, so we're going to keep that. We're going to say if it's our own traffic, if we're causing the traffic to go out of us to come back to us, we're good with that. If it's our own information, we're good. As long as it's not coming from somewhere else, we're okay with that. So we're going to keep this as well. Then we have an input, and this is a new state, which is going to say it's the HTTP destination port. It says accept. This one, it doesn't tell us to do that. We do have something here that says allow HTTP from blue to red, but it does say required for patching. And I have to assume that we want the ability to patch as well. So when it comes down to this, I think that it wouldn't be the biggest deal to keep it in here, but ask your teacher. What I'm going to do, just because it doesn't say so, I'm going to get rid of it. Another one says input dash M state new, and this is 22 for SSH. Once again, we do not want SSH from anywhere other than blue to red, so we don't want 22 here. We definitely want to get rid of this line. HTTP, we aren't really going to be accepting input. We're more going to be sending it outward, so we probably don't want this, but it might be important. I'm going to get rid of it, but we definitely don't want 22, and we definitely don't want 25, which is your SMTP. It doesn't mention anything there. So when it comes down to these three lines, we're going to get rid of them. The last thing says A input, J reject. So that means anything else trying to come into this virtual machine, we're going to reject, and that's good. We want that. Then we have something down here that says dash A forward, J reject, and that means everything that's coming into this virtual machine to forward, we're going to reject, and that is a good line to have, but just not yet. So let's make some additions. What I'm going to do first is get rid of these three lines. Okay, so I've gotten rid of these three lines, and what I'm going to do is I'm going to just make a new line after the last input. And what we're going to do is we're going to say this: forward dash m state dash dash state established related j accept. So we have an input that says keep any connection that's coming into this router. So if it's already been established, keep it going. If it's related, keep it going. We also want to keep that as a rule for our forwarding packets. So when it comes to forwarding packets, if we've created a connection, we want it to still remain connected if it needs to be connected. So you have to make sure this established related statement right here is also put in there for forward. So input and forward are essentially going to have the same statements. You just want to make sure that one says input and one says forward. Again, all this is doing is allowing you to maintain connections if they need to keep going. So that's going to be really important. The next thing is we want to be able to allow SSH from blue to red. So this is where we're going to type in a forward mstate dash dash state new, and then what you're going to do is you're going to type in dash m tcp dash p tcp dash dash d port or destination port 22, that's SSH, and we only want it from blue to red. We don't want it red to blue. So we have to be specific. This has to come from this interface right here. So Eth1, it has to come from here only. If it comes from this port, it should reject it. So how we do that is we type in -i, which is your input, and we're going to say ETH1. That way it says, okay, I'm going to forward any new SSH traffic as long as it's coming out of here. And then say J accept. So that looks good. Let's move on down to this part where it says allow HTTP from blue to red. So we're going to basically do the same thing. A forward m state. Let me just get rid of this dash. We didn't need that dash there. State new mtcp dash p tcp. Destination port is going to be 80 dash I ETH1 dash J accept. Alright, so now we have HTTP traffic that is allowed from blue to red. We have SSH traffic allowed from blue to red. Next thing we want to be able to do is ping. So we're going to say dash A forward dash P ICMP J accept. We want it on both sides, so we don't have to say input Ethernet, or sorry, I would say Ethernet, but Eth1, we don't have to do that. It's going to go both ways. So this is a very simple. It's very similar to A input dash P ICMP J accept. Instead of just inputs, we're allowing forwards as well. So that's really, really good. So now that we've done that, it says nothing else. Well, that's what this says right here. Dash A forward J reject. We're saying anything else when it comes to forwarding is going to be rejected. So we're good with that. Let's just go down here. We can do one more statement, which is an output statement. And we can say allow everything to go out, because we're okay with every bit of packets coming out of us if it's from this router. We'll let the other virtual machines basically decide whether they're going to accept it or not. So I'm just going to say dash A output, and we're going to say J accept. And that's it. So I'm just going to look this over and make sure that everything makes sense. So we have our established, which I explained already, and that's good. We have that our virtual machine is going to accept pings. We're going to accept traffic from ourselves, and we are going to reject everything else. And I think that that makes perfect sense when it comes to all the inputs. Like I said, if you want to put in the HTTP, you might be able to, but it doesn't say anything about having HTTP in here. And the more I think about it, the more I realize when you're patching anything, it's most likely going to be coming from this build server, so I'm not going to put in that. The next part is forwarding, and we have the forwarding established related statement, which is perfect. We went down here and we said, okay, we have 22 and 80, which is HTTP and SSH, and it's only going to be allowed from blue to red, so that is perfect. We have our ping, so that is perfect. And then we've rejected everything else. We basically said, okay, anything else is going to be rejected, and it says that that's what we want. Allow nothing else. When it comes to output, if it's anything coming out of this router, from this router, we're just going to let it happen. Now that you have all these statements, if you have it like this, you can basically exit, save it and exit, bring it up. The reason why I suggest this, even though I'm going to restart everything anyway, is if you have any errors with your firewall, this is the time it'll let you know. So I'm going to say service IP tables restart, and I got all okays, so that means there were no problems, there were no syntax issues, so I should be good right there. So now that I've done this, we can go down and we can work on this, which says we must make sure SSH only listens on the blue network, and it tells us we're going to be editing this file. So this is pretty easy to do. You're going to use the VI editor to edit a file that's located here, /etc/ssh/sshd_config. And just right here where it says listen address, just uncomment it out and type in 10.2.0.1, meaning we're only listening for SSH traffic right here, not on the red network, only the blue network. So go ahead and save that, quit, and you should be done with R01. So once you're done, go ahead and shut it down or restart it. I'm just going to restart it, and that way all the services will restart, and I should get no problems. R01 should be done, and we can move on to G01. So I'll just make sure that this is good. There we go. So I didn't have any errors. That looks good. I'm going to minimize this, and we are going to go to G01. So G01 is a little bit trickier. There's a couple things that we have to do. Right now, it is still on the red network. So what I'm going to do is a couple things first before we get it onto the black network instead of the red network. First, I'm going to basically make sure that we have R01 as the default router. So how we're going to do that is we're going to type in first, let's make a copy of this file. etc sysconfig network. We're really just going to be adding one line, so it shouldn't be the biggest deal, but we're going to do it anyway, just in case. Now let's use the VI editor to edit that file. So it is /etc/sysconfig/network, and we're just going to add a statement that says gateway equals 10.2.0.1. So that way we're saying that the gateway for G01 is going to be going here. Go ahead, save that and close. Another thing that we have to do, and it doesn't really tell us here, but we have to make sure we have an explicit route to the red network. So we're going to do what we did right here for BO1. Let's create a route, but it's basically going to be -ETH1 because we want it to basically come out of here towards the red network. So we're going to type in vi/etc/sysconfig/network scripts route ETH1. But we can do something very similar. We can say address 0 equals .10.1.1.0 because that's the red network. Netmask 0 255.255.255.0, and then we're going to say gateway 0, and that's going to be 10.2.0.1. So that's your gateway. This is the red network. We have a prefix of 24, so that's why we have that net mask. And the network for red is 10.1.1.0. Okay, we're good with that. So we've got the default router. We have an explicit route, but we're not on the black network yet. So what I'm going to do is edit my eth0 network file. Let's go in there. And we can get rid of this hardware address. We'll do it after too if it shows up, but might as well do it now since it's already here. When it comes to the IP address, we're going to change that to 10.3.0.10. That's shown right here. Net mask is going to be 255.255.0.0. Don't believe you'll need the NM controlled. And we can save this. Now that we've done that, I want you to actually shut this down, not restart it. We're going to shut it down. So shut down -H now and let it do its thing. Once it's done, we'll go into VirtualBox Manager and we're going to change its network settings. Okay, so go to G01, go to Settings, go to Network. The first net card is all we're really going to be changing. We're going to change it from internal network to host-only adapter. Make sure you have that set. Advanced should still have the FAST3 adapter type, but if you don't for whatever reason, make sure you change it. And if you want, you can check adapter 2, but these settings should still be the same. So go ahead and say OK and restart G01. It should now be on the black network, which is great. Minimize the manager. And let's just talk about what we're going to do here. So for configuration of G01, we've already set the default router, so that's good. It says we're going to allow SSH from nodes on the black network, but disallow all other network services. Okay, cool. We're going to disallow packet forwarding in the kernel and in the IP tables. Technically, we don't even have to do anything for this, but I'll explain how you can do it. But it's already done for us. We're going to allow pings, and then that's it. That's all for the IP tables. We are going to make sure that we don't allow root to log in via SSH, so we are going to make sure that we copy the SSH d_config file as well, because we're going to be editing something in there. But we have to create some accounts. So we're going to create Alice, Bob, and Boris. We're going to give them passwords, and then we're going to give them groups, specifically Alice and Bob, not Boris, because we want to make sure that Alice and Bob are only the ones allowed to log in via SSH. And it says accomplish this by limiting SSH access to the group Acme ADM. So I'm going to show you how to do that. And then we're going to configure TCP wrappers, and I'll explain how to do that as well. So let's just go in here and log in as root. And let's just copy the files that we need to copy. So very first thing is I'm going to copy and make a backup of the IP tables. There we go. I'm going to copy this file, the SSHD config file. Make a backup of that. Perfect. And anything else that I should... We're going to make a copy of the TCP wrappers, but I'll do that after. I don't want to confuse you just yet, because that I'll explain. So let's go and create these accounts first. I know that we have some IP tables that we want to figure out, but we might as well do this because that's probably the easiest thing to do, is create these accounts, get them groups, and make sure they're all set up. So we're going to say user add, and we'll say Alice. I'm going to say -m, make them a home directory. I don't know if that's going to be needed for the next labs, but we'll do it anyway. We'll say Bob and Boris. Now let's give them passwords. And up to you, I'm just going to say user pass, and that's good. Do the same for Bob. And same thing for Boris. Okay, now I'm going to add only Alice and Bob to a new group. So let's say group add first, Acme ADM. And now we're going to say user mod dash A capital G. We're going to say Acme ADM Alice and Bob. Okay, so if you've done this and you followed me, then we created these accounts, and that's essentially all we've done. We did add a group, but this is going to be something we're going to do down the road. So let's start with IP tables, and we'll work our way down. So let's go into the VI editor and edit these tables. Nice thing is you already know that this input of allowing established related connections we're going to keep. We do want to be able to ping. It says allow pings, so we're going to allow the pings. We don't have to forward any pings, we just have to allow them, so that's good. We can accept our own traffic coming in to ourselves, so we're going to allow the loopback interface. That's fine. So now we have these inputs. So there's an input for new HTTPD or HTTP traffic. We don't want that. The Geo1 doesn't want to accept any of that. We don't want to accept SSH unless it's going to be coming from the black network, so we're going to have to modify this line. And then 25, which is SMTP, we don't want anything for. So let's get rid of 25 and let's get rid of 80 for now. There we go. Now when it comes to SSH, like we said, we only want it coming from the black network. So that means that we only want it coming from this NIC right here, or this interface right here. So all we have to do is type in -I for input, ETH 0. And now SSH will only be accepted coming in to this interface, not from blue. And that's exactly what we want based on these instructions down here that say allow SSH from nodes on the black. So that looks good. Let me just see if there's anything else that we should be doing. For the input, we're going to reject anything else. It doesn't tell us to reject anything else, but we'll do it anyway because RO1 said that, and I think that that is kind of implied. Now it says that we have to make sure we disallow packet forwarding on both the kernel and the IP tables. Well, we already have a comment right here, a statement that says forward, and we're going to reject everything. So we're going to leave that there. So that's perfect. If we want, we can put that output J accept. We can allow all output out of our virtual machine, and that's fine. But that's all we have to do. This one was very simple. Once you understand IP tables, and we went through a lot of it with the router, so hopefully you understand what I did here. This is all you need to do. Now it does say on the kernel as well what that meant. I'll show you. We can save this and quit. And just really quickly, let's just make sure we didn't have any syntax errors. So service, IP tables, restart. We're good. Okay. So what we meant by make sure the packet forwarding is not allowed in the kernel is just that same file that we had edited in the router. So it's etc/syscontrol.configuration or sysctl.conf. It's just this line right here. We had changed that to a 0 to a 1 to allow IP forwarding. We are just going to leave it 0. That's all it means. So we actually didn't have to do anything here, which is nice. But it's nice to know what that means, just in case it's on a test. So go ahead, and we can just quit this. We didn't actually do anything here. And now we've done everything with IP tables. Let's work with SSH. So what we're going to do is edit that file. So this is the file right here. This is what we're going to be editing. Hit enter. And we want to make sure that root is not allowed. So we're going to go down and find something that says permit root right here. Permit root login. So go ahead, insert, uncomment that out, and just change that from yes to no. We've already created the accounts, so the next thing is we want to make sure only Alice and Bob can use SSH, but we have to make sure it's allowed by the group, not by each of them individually. So how we can do that is just scroll to the very bottom. We're going to add a new line. It's going to look like this. Allow groups, space, and put the group name. Acme ADM. So once you've put this line right here, you can save this and quit. And you're done with SSH, almost. The last thing we have to do is configure TCP wrappers to allow SSH only from a list of specific nodes on black. It says include the host in this list so that you can SSH to the gateway. So this is where we're going to learn something new. I'm going to just clear this. I'm going to show you something and then we'll get into it. It's actually pretty easy to understand. Basically, TCP wrappers look at two files, and I'll show you what those are. If we go to host dot, we can see there's two files. So we're used to just etc/host, right? But if you say host dot, you'll see that there's actually an allow and a deny. The way that this works is kind of similar to ACLs, except it's a little bit different in terms of explicitly the explicit deny at the end of ACLs that you're used to from Cisco. What this one does is it checks the allow first, and it sees everything in this allow file, and it says, okay, when I'm trying to do something like use SSH, I'm going to look at the allow and see if it's going to allow it. And if it's in there, it's going to allow it. If it's not in there, then it moves over to this deny file, and it looks in the deny. If it's in there, then it's going to deny it. But if it's not in there, unlike ACLs that we're used to from Cisco, it's going to allow it. So if it's not in either of these, it's going to allow everything. So again, remember with your Cisco ACLs, if it wasn't in the ACL list, if it didn't fall into that chain at all, it assumed deny all. These are the opposite. If it's not in any of these files, it assumes allow all. So that's the real difference. But like I said, it's going to check the allow first. If it doesn't find what it needs to allow, it'll check deny. And if it's not there, then it allows. So what we're going to do is we want to make sure that SSH is allowed for a list of nodes on the black network. Specifically, we want this IP address. So let's just edit the allow first. And how you do that is very simple. You're going to type in the service name, so SSHD and colon, and then you're going to type in the IP addresses that you want. So 10.3.1.1. If you want, you can type in another one like 2. You can even type in 3.0.10. That's this guy right here. But we just want a list from the black network, and that should be sufficient for what we want. So we don't have to do anything more than that. If you only want these two IP addresses, that's fine as well. You can deny in this file. So just so you know, you can say SSHD space all, and then we can say deny. And this would actually work. You don't even necessarily need to go into the deny file. You can put it in here and that will be sufficient, but just to get you used to using the deny file, I'm just going to save this and quit, and we'll edit the deny. And we're just going to say SSHD colon all. Because this is the deny file, we don't have to say all deny. This will just know if I'm saying SSHD all in the deny file, it's going to deny it. So go ahead and save that and quit. And now you can just shut this down or restart it. I'm just going to restart it. And it's going to apply all of the settings, and hopefully we should be good. So I'll wait for that to go. How we're going to figure this out is we're just going to test all of this, and we'll see if it works. And then once you can confirm that all of this works, just run your scripts and send it to your host, submit it, and you should be good. But I think that's everything. I don't think there's anything more that you need. Just remember, if this did work, save your virtual machines and make sure you have a backup just in case. So I have GO1. It's all ready to go. Let's just check BO1, and we'll start with BO1, see if we can do everything we need to. So I'm going to clear this. And first thing is I'm going to ping every single one of these guys. So I'm going to say ping dash C. I'm just going to put 2. And R01 red. That's good. Blue. That's good. Geo1. That's good. Alright, so let's try to SSH to R01 now. SSH root at R01. Enter. Nothing. Okay, so we have done all of these. Actually, we'll do it for Geo1 as well. Good. So BO1 is good. It's perfect. Everything works good. For R01, we only have one thing to do, which is SSH into Geo1. So let's go here. Root. SSH root at Geo1. That didn't work. Let's just try Alice as well. Didn't work. Okay. So we want to make sure that it's not going to work for either, and that's perfect. So we can move on to Geo1 now. So let's just minimize this. For BO1, minimize. Here's Geo1. Let's just make sure that we can ping. Ping dash C2 BO1. Nope. I have to log in first. That would make more sense. There we go. Sorry about that. Alright, let's try this again. Ping C2 BO1. That worked. Perfect. And we can try the router, but it should work if we can do that. So we can say R01 blue, R01 red. That's good. So let's just clear this, and let's do the next thing, which is SSH to BO1. We should be successful. Root at BO1. Yes. And I'm in BO1. So just make sure you exit, but we were successful, so that's good. So let's do this now. We're going to type in wget. Now we don't have this file, or at least I don't have this file in my server, but that's okay. We're just going to type this in anyway. And we get error 404, so that is perfect. Okay, so now we're going to check our host, and we're going to see if we can SSH into any of these. Alice and Bob should work, Boris and root should not. So let's command prompt this guy up. Type in SSH. We'll try root first at 10.3.0.10. If you get this, that's okay. I'm going to show you how to get rid of this. All we have to do is go into this PC. Should be, yes, users, your name. You'll have a folder called .ssh. You can just delete this. Try it again. There we go. So we get permission denied. So even though I'm putting in the right password, it's not letting me. Perfect. So we'll clear this. Oh, there we go. Try it again with Boris. SSH Boris at 10.3.0.10. Enter the password. Permission denied. Just going to try it again. Make sure I put in the right password. Perfect. Let's try this again, but we're going to try it as Alice. And look at that. I'm in. So that's perfect. Let's exit this. Try it again as Bob. And we are good. So there we go. We are done. That basically worked exactly the way we want. All of this came out exactly the way it should. So all you have to do, once again, is make sure you save these. Don't forget to remove the hardware lines. I'm going to show you that right now, just in case. So just get rid of this hardware line. You can probably get rid of this too. I don't think we need that. Save it. We already did it for F0. and it's not there, so that's perfect. And then if you want, you can shut down, restart, make sure that it still works. Do the same thing here. Save it. There we go. Shut down -R now. And I'm going to leave BO1 to be its own and let it do its thing. I believe that we only need to do it for the router and for the gateway. But once you do that, go ahead. Once it restarts, check it that it's still working, that everything's fine, but it should be. And that's it. That's how you do this lab. It's not super difficult. Once you've done it a couple times, it becomes to make sense a lot more and more. So it might be beneficial to do this a couple times, but it's really just a matter of figuring out, what do I do first? What do I do next? You aren't given the step-by-step instructions, and it feels like you're going back and forth a lot, but it's actually not too bad in my opinion. Hopefully this made sense. If you have any questions, feel free to let me know, but I hope that everything worked out well for you. So I will see you in the next video, and thank you very much for watching. See you guys.